Hello all. So in the last few sessions we were discussing about statistical learning and data pre-processing. Also we have seen how data pre-processing is very important in the context of machine learning. So for the machine learning model that we train and develop, the input would be a data set or a data. So before we actually apply the data to the machine learning model, we have to pre-process the data for yielding better results. When I say yielding better results, for proper training of the machine learning model or for getting good accuracy of the model, it is important that the model is fed with the proper data. So today in this session I would like to cover about how do we do data preparation and data pre-processing using a sample data set. So before we actually go into hands-on session, I would like to discuss or quickly brush up what did we see in data pre-processing. So as seen, data preparation and pre-processing are very important when we try to build machine learning models. Here the main goal in data pre-processing or the main aim is to create the clean data or the structured data or create a proper format of the data that will actually be more suitable for machine learning model to yield good results or to make appropriate or accurate predictions. Okay, so let's walk through the main steps that we do in data pre-processing as discussed earlier. First we will look into the columns and drop the columns which are not required, and this we will do by correlation. Okay, in data pre-processing we have done correlation, right? So we will see in what way the columns are dependent on each other, and depending upon correlation, covariance and causation will decide what are the important columns that has to be included in the data set, and you can discard the other columns. And then how do we handle with missing data, because missing data often creates noise in the data with which the performance of the model would be affected. So we will have to handle the missing values, and we do handle missing values by replacing the missing values with either a mean, median or mode. So central tendency comes into picture here. Okay, statistical learning concepts of correlation, causation and covariance comes into picture here, and then dropping duplicates. If you find multiple duplicate values in the same data set, it is waste of time processing the same data again and again, so we drop the duplicate values. We divide the data into train and test the data, because train data is used for training the model and test data is used for testing the performance of that model. And then there's another important concept called feature scaling. As I told you earlier, feature scaling is actually used for scaling the values in the features. Each and every value, each and every feature may have different range of values. So when we often train the model will misunderstand about the importance of each and every variable. It may assume the variable with higher values of higher importance, or the variable with higher values may dominate the variables with lower values. So in order to avoid that discrepancy, we'll go for this important data pre-processing steps which is called as feature scaling. Okay, so today in this session I would like to talk about how do we pre-process the data by loading the data set, how do we handle missing values, how do we do encoding, that is handling categorical variables, how do we detect outliers and handle them, how do we do feature scaling, that is giving equal importance to all the features despite of the values that they have, and then how do we do data splitting, that is training and test data. So before we actually go into all this, let me explain you about standard scalar. Here I have taken two features. Okay, I have one feature A and feature B. As you observe, in feature A I have the values ranging from 1 to 10 to 50, whereas in feature B I have values ranging from 300 to 600. So if you take any data set, you may have multiple columns or multiple features, and each feature may have different types of representation of the data. So here I am taking numerical data, but when I compare these two, feature has values in low range, that is from 10 to 50, and feature B has high values ranging from 200 to 600. So when machine is often fed with this kind of data, it may understand that feature B is dominating feature A because it is having greater values. So the machine should not be given that idea, because that may avoid or discard feature A thinking it is of no importance. Okay, so in order to avoid this discrepancy, we will go for applying standard scaling to this particular data. So in order to do scaling, what we do is first we will calculate mean and standard deviation. So in statistical learning we have seen how to calculate mean and standard deviation, right? So for feature A, mean is 30, and for standard deviation of feature A is 15.81, whereas when you look into feature B, the mean is 400 and standard deviation is 158.11. So there is a huge difference between the mean mean and standard deviation values. So in order to avoid this thing, what we do is we standardize the data. So for scaling this particular data, we go for x minus mu by standard deviation. That is, we go for taking the x variable for different values of x. We take the deviation of x with respect to mean by the standard deviation. Okay. Now when you look into feature A and feature B here, now all these two features, feature A and feature B, for every sample they hold the same value. Okay. This is how I standardize the data. Now when you give, we are not supposed to give machine this data because of different range of values in feature A and feature B. So in order to give equal importance to feature A and feature B, we apply standardization, with which now you can see feature A and feature B holds same values. Okay. So 0 mean represents after standardization both features have a mean of 0, and unit variance, the standardization of each feature after standardization is actually 1. Okay. So this particular step standardization helps us in making sure that each feature contributes equally to the model. None of the feature will dominate other one. Okay. Now let's go on to the hands-on session. Okay. Now let's start working on how do we create a data set, how do we load that particular data set and handle pre-processing. Okay. First is, let me create a sample data set. Okay. Now I have created a sample data set here. First I say import pandas as PD, and then I'm creating a sample data set. I'm just taking a dictionary because I want to take key value pairs, where the key would be the columns that I'm trying to create, and these are the values. I have taken 4 columns. One is age, second one is income, third one is gender, and fourth one is purchased. Okay. Out of these 4 columns, the first three columns, age, income and gender, would be my input columns, and the output column would be purchased. That is, I want to check if a person can purchase a product or not based on his age, income and gender. Okay. So I've created a simple dictionary with key value pairs, and I'm trying to create a data frame of it. Okay. Now I say enter. Okay. Now as you can see, I have created a simple data set. Here as you can see, I have 4 columns, out of which age, income and gender would be my input columns and purchase would be my output column. Now when you closely look into these columns, age column has one NaN, that is one null value. I wantedly created some null values here. So in the age column, I have created one simple null value which is called as NONE, none, and in the income column also I have created one null value. Okay. I want to simply run this particular data set and check whether null values are displayed here or not. As you can see, null values are represented with NaN. Okay. Now in the first step of data pre-processing, I want to handle the missing values. Okay. How do we handle the missing values? We handle the missing values by imputing them with central tendency. Okay. So we have 3 measures of central tendency: mean, median and mode. Okay. So which one to choose depends upon the values and depending upon the type of column that I have. So when I talk about age here, I would like to observe carefully the values. So the age values are approximately all of them are in the same range. So I go for taking mean. So when I go for income, I'll go with the middle value. Okay, depending upon the values, you can choose any of the central tendency measures to fill the missing values. Okay, now to fill the missing values, what I do is I load the data frame. I say df of age, okay, dot, I use this numpy function which is fill, pandas function which is called fill na, and then I say df of in the age column. Okay, in the age column I want to fill that with mean values. Okay, you can also choose median here. Okay, and then I say in place is equal to true. Okay, so in place function here is actually used such that wherever, not just for one place, wherever I have null values in the age column, that all the columns, all the row values of NaN should be replaced with the mean value. Okay, similarly I'll do it for income. I say df of income dot fill na df of income dot median, and I say in place is equal to true. Okay. Now I am trying to replace this NAN in H column with mean and this NAN in the income column with median. Okay. Now I say print DF. Okay. Okay, as you can look into this, NAN column, in the H column I have NAN and I have replaced that with the mean value, that is average value in the H column, which is 34.4. Similarly, in the income I have applied median and the median value of this particular data 30, 50, 60, 70, 80. Okay, so median value would be 60 and that is taken into consideration. Okay, so this is how I replace missing values with mean, median or mode, and this is where the central tendency comes into picture. Okay. Now once I am done with replacing the middle values, let's see how do we do encoding for categorical variables. Okay. So when I talk about categorical variables, I have a gender column here. Okay. Now in gender I have two particular values, male and female, but I don't want to take them as values in the gender column, but I want to separate male female into two different columns. Okay, for which we apply one hot encoding. Okay, so we need to encode the categorical variables, for which we will be using one hot encoding or label encoding depending upon the nature of the categorical data. Now for this particular column called gender, I would like to apply one hot encoding. Okay, so let's do one hot encoding. Okay, for doing one hot encoding, I'll load the data set and I say pd dot get underscore dummies. Okay, I want to create a dummy column in the gender column. From the data set, I want to access this column which is called as I want to access this particular column which is called gender, and then okay, I want to create a dummy column out of that gender column, and now I say print df. Okay, now as you can see, I initially had only one gender column with two different values, but I want equal importance for male and female, that is the purchase history actually doesn't depend upon male or female. Okay, I want to take them as two different columns, for which I have applied one hot encoding. Okay, so in one hot encoding I have simply created a dummy column for the gender column, for which my gender is displayed as gender male and female. Now in this particular thing, as you can see, wherever you have male in the gender column, that would be applied as true in the gender column. So here I have male, female, male, female, female, male. Okay, so wherever you have male, true would be displayed. Wherever you have female, false would be displayed. Okay, whereas in the female column, wherever you have female, true would be displayed. Wherever you have male, false would be displayed. So this is how I do one hot encoding. Okay, so this is all about how do we read a data set. Okay, how do we create a data set, how do we read that data set and start working on pre-processing. So the first step in pre-processing that we have done is handling missing values, and in the second step we have performed one hot encoding. In step 2 we have performed one hot encoding. Okay, so in the next session I would like to cover the remaining pre-processing steps, that is label encoding, outlier detection, and then we will also see feature scaling and train test splitting of the data. Thank you.